If you're ready to do math today and you have your coffee ready, join me in the simultaneous sip. The question we're working on today is, CDF Appliances has assembly plants in Atlanta and Fort Worth where they produce a variety of kitchen appliances, including a 12-cup coffee maker and a cappuccino machine. At the Atlanta plant, 160 of the 12-cup models and 200 of the cappuccino machines can be assembled each hour. At the Fort Worth plant, 800 of the 12-cup models and 200 of the cappuccino machines can be assembled each hour. CDF Appliances expect orders for at least 64,000 of the 12-cup models and at least 40,000 of the cappuccino machines. At each plant, the number of assembly hours available for these two appliances is constrained by each plant's capacity and the need to fill orders. Write the system of inequalities that describes these assembly plant constraints and graph the solution region for the system. So we'll let X be the number of hours that's worked at the Atlanta plant, and we'll have Y be the number of hours that's worked at the Fort Worth plant. And we have to read our problem to figure out what are the constraints of X and Y. So we'll start by looking at the 12-cup model. And we need to make at least 64,000 of these. Well, the Atlanta plant could make 160 per hour, and the Fort Worth plant could make 800 per hour. So our constraint is 160 times the Atlanta hours, which is X, plus 800 times Y must be greater than or equal to 64,000. And now we could look at the cappuccino machines. We need to have at least 40,000. Atlanta could make 200 per hour. Fort Worth could also make 200 per hour. So our constraint is 200X plus 200Y has to be greater than or equal to 40,000. And of course, the number of hours worked at both of these plants must be greater than or equal to 0. So I plotted these lines using Desmos, and we want to figure out what region satisfies our inequalities. So let's first find that vertex that isn't labeled. And the way we do that is we solve a system of equations. I found it was easiest to divide the first equation by 160 and divide the second equation by 200. And now we have a system of equations that's easy to solve. Let's subtract the second equation from the first equation, and we have 4y equals 200, or y equals 50, and we can see that x has to be 150. So that vertex is 150, 50. Now let's take a test point. We could use the origin because it doesn't lie on either of the lines. When we check with the first inequality, 0 is not greater than or equal to 6,400, so we'll shade to the right or above the red line. And similarly, 0 is not greater than or equal to 40,000, so we'll shade to the right or above the blue line. The region that shaded both blue and red will shade in black. So this is our solution region for the system. Make sure to subscribe for more Coffee and Math with Dr. Wesselcouch. Don't text and drive. Bye-bye.